Here's a simulation of what we're thinking about. I found it helpful to look at, to visualize. I can use my cursor to step through this and see that the swimmer reaches the front of the raft right there. That's at 4 seconds into this simulation. And then 0.8 seconds later is at the other end of the raft, so it's 4.8 seconds. I had defined the velocity of this to be 1.5 meters, and this was 1 meter per second. 1.5 meters per second and 1 meter. This was helpful. It gave me position values and time values to check my work and make sure the equations I was coming up with were working, that they were valid. So here's my work on paper. I'll go through it quickly, and you can give me feedback if you can. Here's a diagram of what we were just looking at, and then down here I'm going reference to the front of the raft is the start. When the swimmer gets to the front end, that's that event. I call that from start to that event T1, and then from the time the swimmer swims from the front of the raft to the back, I call that time T2. Relative to the shore, relative to the raft, I'm thinking about velocity, and the velocity of the raft is V, the swimmer is C. I have this in there, the relative to the shore is not moving. For the raft, the velocity of the raft relative to the raft is 0, the swimmer is C minus V, and the shore is moving at velocity V, all this relative to the raft. That's during the up part of the swim. On the back part of the swim, again, raft velocity is 0 relative to the raft. The swimmer's velocity is C plus V, and the shore is moving at velocity V still. Thinking about total distance, again, relative to the shore, relative to the raft. Here's my thinking here. The total distance relative to the raft, of course for the raft it's 0. For the swimmer it's C minus V times T1, that's on the up trip. C plus V times T2 on the back trip. And the total distance that the shore travels relative to the raft is just the velocity of the raft times time. Rob asked, how far did the swimmer go? I thought about that relative to the shore, relative to the raft, relative to the swimmer. For the shore, relative to the shore, that he went his velocity, which is C times the time, or breaking that down into the two parts right there. How far did the swimmer go relative to the raft? Well, he went down the raft and back up, so that's just 2D, and relative to himself did not move, right? That's trivial, I think. Relationships I can see on the up trip. This relationship, this first one holds. I call this line 1. On the back trip, this is a relationship that holds. Now from this I can define D, which is the length of the raft, just define it a different way from the up part of the trip or from the back part of the trip. The total distance D of the swimmer is the distance on the up trip plus the distance on the back trip, and I have these things written out. I used the things above to do it another way. Again, the distance on the up trip, distance on the back trip, a different substitution here, and I end up with this. So this is where I'm at. I've tried to go in different directions to arrive at the equation that Rob had said we would get to, and I haven't gotten there. So if you see anything here that looks promising and you give me feedback, I would appreciate it. Just to continue numbering my lines here, I would call this line 5, 6, and 7, 8, 9. Thank you very much.